Proof for laws of refraction using the Huygen's principle. So the before topic we have seen about law of reflection using Huygen's principle. So now we are going to see about refraction using Huygen's principle. So for that we are taking the same medium, because the law of refraction and reflection first point will be same only, because the incidence, the reflection and the normal should lies on the same plane. So here also the same thing. So this is the incident 3 rays and this is the incident 3 rays, and also one incident is perpendicular to the M to B dash, how we saw before. So now this incident will be refracted in this way, okay, because so here we are seeing about refraction, so which means rarer medium to denser medium. So rarer to denser, the refraction will be towards the normal, okay, towards the normal. So which one is normal here? The perpendicular to the plane, the line which is perpendicular to the plane, which means the surface. So here I have one perpendicular line, and in the mid I have one perpendicular line, and in this I have one perpendicular line. So first I am going to consider this ray alone, okay, this incidence and this refraction, this incident and this refraction. So we know that this is the incident ray, which is normal, the incident ray. So this angle is incident angle. So the refraction angle will be in this side, okay, this refraction angle will be this side, and here also I have the normal, so I have marked it with n dash, okay, this is n dash and this normal is n. And to calculate the remaining angle, we will minus it with the 90. So why 90 and all, you know, because it will be like this, means normal. To find out this angle, we will take 90 minus and this angle. So like that only we will check. So this is what we are going to do here. And so here we have a little one most important thing. So this is the medium 1 and this is the medium 2. Okay, so medium 1 means is nothing but the velocity 1 and the velocity 2. So here I will have a fastest velocity, okay, the fastest velocity in the medium 1 and the less velocity in the medium 2, because this is denser. Okay, the density will be high in the second medium. So always the V1 is greater than the V2 for rarer to denser medium. Note down the rarer to denser medium. Clear? So this line is perpendicular. This incidence is perpendicular to M B dash, and this reflection is perpendicular to A and A dash. Okay, hope you don't have any doubt in this. Okay, so first, okay, we will take the formula. So we are going to deal it with this Snell's law, because the law of refraction, the first rule is the incidence, refraction and normal should lies on the same plane, how we saw for the reflection. So the first rule will be same for reflection and refraction. But the second rule for refraction is Snell's law. So you know what is Snell's law. I have written all the formulas that we are going to use in this derivation. So Snell's law is sin I divided by sin r is equal to n2 minus n1. And we know sin theta formula is opposite by hypotenuse, and the velocity formula is displacement by time. Okay, so just we are going to modify this formula. Velocity is equal to d by t. Okay, so first we need what? T only. Okay, t only we need. So for that I am just changing it with d by v. Okay, so first we will see for the rarer medium velocity. Okay, so what is rarer medium? In the rarer medium, which one is the incidence? Yes, so this B and B dash, okay, this is the B and B dash, okay, so B dash divided by, and V is nothing but the V1, okay, and for denser, same only, apply in the same formula, T is equal to D by V, no, the same formula, which is A and A dash and by V2, okay, because this is the incidence, okay, this plane only the incidence is coming, okay, so from M to B dash, okay, so I am taking it from this line, so B to B dash, and here which is perpendicular, the A and A dash, so A dash divided by V2. Okay, so now I can write this equation as B dash by V1 is equal to A dash by V2. So you have any doubts in this? Very simple. Just I have applied in the velocity formula. I am considering only this ray, the perpendicular ray, incident and the refraction. Okay. So B to B dash is the incidence and A to A dash is the distance. Okay, it covers the distance is A to A, the displacement A and A dash, because we are seeing a displacement only, so we have to tell displacement only. So according to that, I have formed the equation like this. Okay, so now we'll go for the Snell's law. Okay, so because the second law we need to prove it by using the Huygen's principle. So what is Snell's law? Yes, so sin I divided by sin R is equal to N2 minus N1. Okay, N2 minus N1. So first we will see about the incidence. Okay, incidence angle. So incidence angle is nothing but angle I is equal to the same way. Okay, the same way we are going to follow what we followed for the reflection. Okay, so the angle I is equal to what? This is the angle of incidence, N, A, L. Angle N, A, L. Because this is the incidence. Okay, N, A, L. So angle N, A, L is equal to find out the remaining angle, 90 minus. We know this is 90. So 90 minus the same thing, N, A, B. Okay, N, A, B. N, A, B. So angle N, A, B. Okay, so that is equal to this triangle B, A, B dash. Okay, this triangle. Okay, this triangle. Okay, so B, angle B, A, B dash. See, B, A, B dash. Okay, so now we'll see for the refraction. Okay, we'll see for the refraction angle. So angle R is equal to, okay, listen carefully, angle R is equal to, very easy, N dash. Okay, this is the refraction, no, this is the refraction, N dash, B dash, M dash. Again I am telling you, N dash, B dash, M dash. So N dash, B dash, M dash angle. So to find out the remaining refraction, we will take 90 minus, yes, 90 minus A dash. Where is that A dash? A dash, yes, A dash, B dash and M dash. A dash, B dash and N dash. So angle A dash, B dash and N dash. So that is equal to this triangle. Okay, that is equal to this triangle. A dash, A, B dash. A dash, B, A dash. Okay, clear. You don't have any doubts. Yes, so that is equal to this triangle. A dash, A and B dash. So A dash, A and B dash angle. Okay, so very easy, and we are going to take again the two right angle triangles. So we have here one triangle and here one triangle. So two right angle triangle. So what is the Snell's law formula? We need to prove, no, sin I by sin R, which is equal to, so we know that sin I means first for the incidence. Okay, first for the incident, take the two triangle. Okay, the right angle triangle. First we are going to see for this case. So sin I means, so what is the formula? Opposite by adjacent. So this is the, opposite by hypotenuse. So this one is the hypotenuse and this one is the opposite. Okay, hypotenuse and opposite. So B dash by A, B dash. Okay, so I'll write here B dash, A, B dash. Okay, and divided by for sin R now. Now for sin R. So this triangle. So this triangle, which one is the opposite? Yes, which one is the opposite? Here only, no. So the equation will be A dash divided by A, B dash. Okay, so A dash will be the opposite, B dash will, this one will be the hypotenuse. Okay, the same plane. For both hypotenuse is same. So the equation will be A dash by B dash. So directly we can cancel this two. So remaining what we will have? B dash divided by A dash. Okay, so this B dash divided by A dash is equal to V1 by V2. Okay, this is equal to V1 by V2. And in our book they gave C divided by V2 divided by C divided by V1. Okay, so how this derivation came means I will explain you now. So this is very important. So first we will take the refractive index formula. So what is the refractive index formula? N is equal to C by V. N is equal to C by V. So for the medium 1, N1, V1. And for the medium 2, N2 is equal to C divided by V2. Okay, so this is the formula we have. For N2 minus N1, how we will change? So sin I is equal to sin I divided by sin R is equal to N2 minus N1 is our formula. So N2 minus N1 means how we will write? N2 minus N1 is equal to C V2 divided by, yes, C by V2 divided by C by V1 we will write. Okay, so then what we will do, just take this to that side. So N2 by N1 is equal to C by V2 into V1 by C. So this C and this C will get cancelled. So N2 by N1 is equal to V1 by V2. Okay, so why I have written V1 by V2 means, so first I will tell you this case V1 by V2 why I have written means, see here I am changing this equation into B dash divided by, listen carefully, B dash divided by, taking this A dash to this side, so you will have V1 by V2. Okay, for this case, okay, while I am applying the opposite by hypotenuse formula, taking the sign, I will get this answer and I can write this as V1 by V2. Again, I can write this V1 by V2 as C divided by V2 by C by V1. So, why means because of this reason only. V1 by V2 is equal to N2 by N1. So, when I apply this in N terms, I can write C by V2 divided by C by V1. So, watch it carefully, you can able to understand. And this sin I by sin R is equal to N2 minus N1. Just you write like this. So N1, yes, N1 sin I is equal to N2 sin R. So hence I have proved the law of refraction by using the Huygen's principle. So you can copy this in your classwork notebook. Both things you have to copy in your classwork notebook. Reflection and refraction. So you'll be having test on tomorrow. Okay, thank you all.